Good morning and welcome back. It is after spring break. Hope you enjoyed yourselves. We are ready to start into more of chapter 5. We kind of skipped the harder parts, although some people find this a little easy. So it's up to you how this works. Uh, we have our Google Meet on Thursday at 10 o'clock. So the way this will work, because yours is Google Meet is late in the week, is I will record uh, Monday morning and have it online for you. And then you can look at it and see what the lesson is, work on it for a couple of days, and then on Thursday, we'll go over a little bit of the homework. We'll go over any questions, and then you can ask questions, and then we'll start on the new lesson. And then the following week, we'll go over it again. I'll go over it again. I'll give you something to watch, and that's how we'll do it for a while. Chapter 5, we only got a couple of more sections, and then we'll have our Chapter 5 test. We had our Chapter 5 quiz, which unfortunately some of you have not taken yet. So get on that. Um, any work that is due, please do it. If a 50 is better than a 0. Please, please, please do it. Okay, let's get to work. So in chapter 5 and section 5.3, we're skipping 5.1 and 5.2. They are really hard, and if we were in class, we would do a little bit, but we're not going to do it over the internet like this. So we're going to 5.3. It's called trig identities. And here's what it boils down to. When you have the cosine of 45 plus 30, now that makes sense. That's 75. We could type in the cosine of 75. But sometimes we have variables here. Sometimes we have things, and it's a lot higher mathematics, but this is what happens. So we have like a cosine of x plus 50 or something like that. The question is, can I distribute the cosine? So is this equal to this? Can I distribute the cosine? And let's see, the cosine of 75, if you plug it in a calculator, is 0.258. And if I do this individually plus this, I get 1.57. So what did we just prove? We just proved that they are not equal. They are not equal. Okay, so is there anything? Well, hopefully you open, I'm going to cough here for a second. Excuse me. Hopefully you open the notes page that I sent you, and this is the first part of those notes. And the question is, are they equal? The answer is no. So what can we do with something like the cosine of x plus y? Well, we could prove this all we wanted. It would take several days, another hard thing. So all I'm going to ask for you is to understand this. You don't have to memorize it. You'll have a cheat sheet, or you can look at your notes for this when you take a test. The cosine of x plus y is equal to the cosine, and this is all on the notes, times the cosine of y minus the sine of x times the sine of y. Again, don't ask where that comes from. Like I said, we could do it, and it would take, if we had school time, because like I said, tomorrow and Wednesday, you're just going to be, if we were in school, I would actually prove this in a couple of days. It's just an interesting thing. And like I said, if you're doing higher level math, if you have to take calculus at some point, you will need to refresh your memory on this stuff. So we'll also see how it comes into play later. So there are basically 6 of these. There is the cosine called the sum, where you have plus in here, and then this is what it's equal to. You have the difference for cosine. So it's the cosine of x minus y. And that's basically the same thing, cosine x, cosine y, except it's plus there. So it's kind of the opposite. If this is a plus, this is a minus. If this is a minus, this is a plus. What you see, another part of the cheat sheet, if you want, if you scroll, if you move downward on the last page, to save time or save space, what they do in most books is they write it out. I'm trying to get my eraser. They write it out like this. Instead of writing it twice, they just write it once. And what they do is they put a plus here and then a minus. So if it's plus, it's the top. If it's minus, it's the bottom. So over here, what they do is they put a minus and then a plus. That means this plus goes with this minus and this minus goes with this plus. How's that for confusion? So we're going to try this for writing the sign. X plus minus y. What the heck is that? Well, that's on your notes. Okay, that's on your notes. And I'm scrolling. It's right on your notes. The plus is the sine of x times the cosine of y. Now this time it's a plus. Plus goes with plus. The sine, or they write it cosine of y. I remembered a different way. Cosine of x, sorry. Cosine of x times the sine of y. And plus goes with plus, and minus therefore goes with minus. I'm not even going to write the tangent. The tangent is in your notes. It's a fraction. Again, you don't have to memorize any of this. This is all in your book. How do we use it? Okay, so let's go to a practice problem. Also on your cheat sheet, if you scroll down, is the chart, the old chart. You'll need to know that. I can erase this too. All right, so we have some practice problems. First one is, what is the cosine of 15 degrees? Cosine of 15 degrees. Now, in this problem, you are not allowed to use a calculator. So what you have to do is you have to think of what two numbers, and our numbers from our chart are 0, 30, 45, 60, and 90. Those are the ones we know. Give me two numbers that add together or subtract will give you 15 from these three, or these five, sorry. Well, 45 take away 30 is 15. So I could rewrite this as the cosine of 45 degrees minus 30 degrees. Okay? There's not many of these you can do, actually, if you think about it. There's not a whole lot of these. So that is equal to the cosine of 45 degrees, I'm going to erase the 90, times the cosine of 30 degrees. Remember, cosine is opposite, so now it's plus the sine of 45 degrees times the sine of 30 degrees. Did you get the 30 on there? Yep. From our chart, this is the square root of 2 over 2 times the cosine of 30. I'm trying to do this off the top of my head. The cosine of 30. 30 degrees is the short one. The cosine is the length. That's the square root of 3 over 2 plus sine of 45 is also the square root of 2 over 2 times the sine of 30, which is a half. Don't panic about too much here. As long as you show me this work, I'm happy. But the square root of 2 times the square root of 3 is 6. 2 times 2 is 4. Plus the square root of 2 times 1 is the square root of 2 over 4. So these are both over 4. So the answer is actually the square root of 6 plus the square root of 2 all over 4. And of course, if you don't believe me, you can do it on a calculator and double check that 15, when you hit this button and you do these numbers, don't do the cosine of this, just do this number. You'll get the same answer. So that's one example. That's not so bad because it's in degrees. What if it's not in degrees? They like to use radians here. I recommend very quickly changing radians. The next one is the tangent, and we'll get into a tangent problem here, of 7 pi over 12. Now, 7 pi over 12 is how many degrees? Remember, you're going to multiply by 180 degrees over pi. That goes in 15 times. When you do this, you get 105 degrees. 105 degrees. So that's what I want to know. What is the tangent of 105 degrees? So, give me two numbers that add together or subtract to give you, well, we can't subtract. So I would use 45 and 60. So this is equal to the tangent of 45 plus 60. Okay? Now we're going to look at tangent. Tangent formula plus looks like this. Tangent of 45 times tangent of 60, all divided by 1 minus tangent, this is all, you don't have to memorize these, times, the numerator is a plus here. Numerator is a plus. This is a times the tangent of 60. Now this one, we don't have to simplify this a whole lot. The other one did simplify a lot. This one, you know what? For you guys, I'm not worried about it as long as you substitute correctly. The tangent of 45 is 1. So this equals 1 plus. The tangent of 60 is the square root of 3 all over 1 minus 1 times the square root of 3. Now this one's not bad because there's no fractions. If this was 30 degrees, you would have a square root of 3 over 3. That makes this harder. So pretty much 1 times that is that. This is your answer right here. Okay, now the only leg left is, what if we wanted to work backwards? What if we wanted to work backwards? Okay, so I'm going to skip to problem 4 on the practice. It's sine of pi over 3 times cosine of pi over 5 minus the cosine of pi over 3 times sine, erase this, of pi over 5. And you go, what is that? Well, if you look at your notes and work backwards, whenever you mix sine and cosine like this, whenever you mix them, that's equal to the sine function. And that's x, and it's the same, minus y. Well, what's x and y? Well, they come from right here. Don't even look at this second one. Look at the second one to see that it's matches, but it's sine and cosine, so it's a sine function. So it turns out the first one is pi over 3, and the second one is pi over 5. Now, you leave it like that, I'm happy. If you want to, you get a common denominator. The common denominator is 15. So this is 5 pi over 15 minus 3 pi over 15, which ends up 2 pi. So the true answer is the sine of 2 pi over 15. You guys, I don't really care. You leave it like this, I am thrilled to death. So it's not that bad, okay? It's not that bad. Now, the homework, a little different than what's on the page. Please pay attention, and I'll make sure I put this on the Google Classroom too. You're going to do 1 through 6, which was like the first type we did. And then 11 through 16 is like this. And I think these are easier because you don't have to do much. So page 425, 1 through 6, and then 11 through 16. Please text or email me if you have any questions, or just wait until Thursday at 10 o'clock. Thursday at 10 o'clock. Okay? Thank you. Let me get my cursor in the right spot so I can stop the video. Why did that pop up? Oh, well, there we go.